So if we want to factor the GCF out of this more complicated polynomial, negative 2x to the fourth y plus 8x cubed y squared minus 4x squared y cubed, we first need to think about what the terms are and what's common in each of these terms, just like usual. So the first term here, negative 2x to the fourth y, you may find you don't need to do this, but sometimes lining them up vertically can help. 8x cubed y squared. There's no particular rule about how to organize these, but we have three terms. Negative 2x to the fourth y, 8x cubed y squared, and negative 4x squared y cubed. This leading term here has a negative out in front. So I'm going to factor out that negative sign. It's going to change the sign of every term. So my GCF is going to contain that negative. And that's not a hard and fast rule. There are different ways to do this. There are different things to think about when you're thinking about factoring that out. But usually it's just kind of nice to pull that out so that the remaining items inside, when you put it back in that order, in this case it's a descending order on the powers of x, you have that leading term on the inside being positive. Again, sort of an optional thing. When I examine the leading coefficients, I have a 2, an 8, and a 4. Well, those are all divisible by 2. But that's really the only thing they're all divisible by. So we're going to factor out the 2. So far we have negative 2. I'm going to leave a little bit of space there. And when I factor out that negative 2 from the first term, I get the invisible 1 for the second term, 8, divided by negative 2 is negative 4. So my middle term here is going to have a negative 4 leading coefficient. This last term, if I have a negative 4 and I divide that by negative 2, I get out a 2. So my last term on the inside there is going to be plus 2 as my leading coefficient. Let's make a little space. Next, let's look at the x to the fourth, x cubed, and x squared. The greatest power that they have in common, the most they have in common, not the most that I see there, but the most that I see in common is x squared. So x squared is going to be what I pull out. Well, in the first term, remember we had that invisible 1. When I factor out an x squared, that's going to leave me with 2 x's left over, so x squared. That second term, when I factor out x squared, it's going to leave me with 1x. And that third term, when I factor out x squared, I don't have any x's left to factor out. Finally, the y's. The most number of y's that they have in common, the greatest common number of y's, is 1y, as in the first term. So I'm going to factor out that y. Remember, I'm undistributing that, right? So if I undistribute this y from the first term, I don't have any y's left. If I undistribute 1y from the second term, I have 1y left. And if I undistribute 1y from this last term, I have 2 y's remaining. So my final answer is kind of spaced weird, so that's the only reason I'm necessarily rewriting it. Just to make it prettier, is negative 2x squared y times x squared minus 4xy plus 2y squared. And remember, we can always check by distributing. If I distribute through negative 2x squared y times x squared, I get negative 2 x to the fourth y. That nicely matches what we started with. If I distribute negative 2 x squared y times negative 4 xy, I get positive 8. Negative times a negative is a positive. 1, 2, 3 x's and 2 y's. So x cubed y squared. And if I distribute to this final term, negative 2 times 2 is negative 4. X squared, there's only x squared. Y times y squared is y cubed. That matches. This all matches. It checks. And we are done.